Alright, what's up guys? So today is the 10th, and I have finished my data transfer modification as of yesterday. Very big milestone, major milestone for me. So it went from a single player text game, and then I converted it. That was like the first 6 months. Then I decided I was gonna turn it into a 2D game where it wasn't just text-based like a MUD, where you could actually, you know, see your cards, etc., etc. And then when I finished that, I was like, you know what? Let me actually let me actually make this a game that you can actually play against someone else. And I was like, well, that would mean, you know, making it 2-player. So like it started off as a single-player text-based game that was like pretend 2-player. Then it became a 2D pretend 2-player game. And then I decided I was gonna make it into an actual online game. So there's the 3 levels, which was basically a year apiece. So the text-based was year 1, then the 2D was year 2, and now year 3 was converting that to online. And we're at the end of that finally. The very last stages of the transition to the online format, and it's been very difficult. So we stopped at line 299 in server pi, so let's just jump over there. So put stopped here, and let's I'm not gonna try to remember what bug we had. Well, actually I can look at the terminal, because the terminal will show me what was going on yesterday. So let us find the okay, it actually won't let me go any further. That's no big deal. We'll just crank up the server again. So we're gonna cd into Canasta main, then we're gonna pi server, then we'll go down here, we're gonna cd main as well, but we're gonna pi client over here. Client's jumped up, now we're gonna do cd main and pi client as well for client number 2. So you can see it cranks up, and apparently it says waiting for the player to join, which means there's some sort of issue. Okay, so here's our bug. It's in 298 in server. So let's go to server 298, and it says none type object has no attribute, send all. So other con apparently has not been assigned. This is okay. So it's saying that none type object has no attribute send all. So let's do Control F and C. So we assign other con to con2 at the beginning of threaded client, or con1 depending. And then we do other con send all. It says none type object has no attribute. Let's see. Okay, so this has got me a little bit stumped, because if I'm assigning it here, but how could it be a none-type object? Let's see. Oh, so it's apparently it still assigns to none. And a way that we can test this would be to change these to an integer. So now, whenever we run this, we should get the same error, except it will say int object has no attribute send all. Okay, so we have pinpointed the issue here. So apparently other con is not being assigned. But wait, threaded client okay. So let's just start from the beginning here. So when it starts, we call what? Start accepting clients. Let's go down to the bottom. So we say if server name is equal to main, server.set timeout 100, server.bind to server listen. Then we say start accepting clients. So bind to server listen. Let's go look at that one. Self.s.bind. So this is binding to the server via the port. I don't completely understand what that means. Actually, like, let me look that up, because, you know, there shouldn't be any code in my project that I don't understand. What is the bind function in Python? So doesn't have a built-in bind function to directly bind function to argument. However, there are a couple ways to achieve a similar effect. No. Sorry, let me be more specific, Gemini. Socket. Is it socket.bind? Socket.bind? Okay, in Python socket module, the bind function is used to associate a socket with a specific network address, IP address and port. To associate a socket Associate a socket with a specific network address. This essentially prepares the socket for either listening for incoming connections, server side, or initiating outgoing connections, client side. Hello? I was gonna cook some chicken. I got some chicken breasts I was gonna cook, and I was gonna make like some sweet potatoes on the side. Uh, yeah, sure, I guess, because then we'll just have both. I mean, it'll get eaten. I eat like a horse, and David don't eat that much, but I'm sure it'll get eaten. It's, all right, yeah, well, no, 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 I'm good. I already ate my little lunch after I got off work, so I'm good till dinner. All right, Mr. Brian, appreciate you. Okay. All right. Second object. You need to, yeah. We this potentially prepares. Yeah. Yeah. Here's a breakdown of what bind does. Socket object. You need a socket object created using the socket.socket function before calling bind. The socket object represents an endpoint for network communication. The bind function takes a single argument, which is a tuple containing the network address. The tuple typically consists of two elements: the IP address, okay, and then port. This is an integer representing a port number on which the socket will listen or initiate connections. Ports are used to differentiate between different services running on the same machine. Server-side program typically uses bindings to specify the address on which it wants to listen for incoming connection requests. After binding, the server can use the listen to start listening on the specified port and then accept to accept incoming connections and establish communication channels. Yeah, so that's what I'm doing, and I just wanted to better understand that function, and I did pretty much what I thought it did. So then we do start accepting clients, which we say while self.c1 online is equal to false, or self c2 online is equal to false. Try con adder equals self.accept, and apparently, so if self connects is equal to 1, self con 1, self adder 1 is equal to con adder. Otherwise, con 2, self adder 2 is equal to con adder, and then current player int is set to 2. And if okay, and this is for subsequent connections whenever a player DCs determines which and then this starts the new thread, and we pass in the connection and the current player integer, and then we start the thread. So that's, yeah, so we create a new thread, we start the new thread. If self current player int is equal to 1, self c1 is equal to true, and then self dot connection equals 1. Okay. And then from there it's threaded client. So client num is passed in as the current player integer, which is either going to be 1 or 2. So then it says if client num is equal to 1, current client, okay, so like, oh, I see, I know why. It's because at that point, other connection. Okay, I see. You can't. I have to assign other connection after, because at this point in time, when other con gets assigned, since this is the first one to connect, other con equaling self con 2 is just equaling con 2 to none, because connection 2 is not established yet. So we would have to but eventually self.con2 does get changed to the connection. So what we'll have to do, I think, is move this assignment. We can leave this one here, because at this point, connection 1 will be established. But this one we can't assign yet. So we'll have to... we will have to move it to be, let's see. So this is the start of the main while loop. While true, self-game start is equal to true. We're looking for, not that. Let's see. Ink data is equal to con.receive. We're looking for send. We want the send section. How do I just see the send section? Okay, here we go. Right here. Wait a second, aren't we not supposed to have draw window main on the server side? Yeah, I don't think we're supposed to have this draw window main call here, actually. Let me put this, let's put note, and this is going to be 5, 10, 24. We're going to say, I don't think we are supposed to call the window name here. Server side. Alright, and so we'll just hold off on that for now. I'll leave it. Actually, I'm going to go ahead and comment it out. Anyway, so, but, at this point, we'll say if other con not equal to none, then send all. Or rather, let's see. So at this point, we send the string of the client num to the associated connection, and then while self.verified ID received is not equal to 2, if ready 0 and num is equal to 0, if int con.receive1 decode is equal to 1, self.verified ID received plus equals 1. Okay, so this is, but, well, that's in, okay, so this is a little bit complicated, I think. I'm refreshing myself on this. So I'm pretty sure what this does is, first of all, it sends the client number from the threaded client server side. So let's just say this is client 1 thread. It sends that client num, which is 1, to client 1 client side. And then it waits with ready to receive verification that the client side received that client num. We set num equal to 0, and we'll see why. And then we say while self.verified ID received is not equal to 2. So currently self.verified ID received is actually equal to 0, I think, because neither one of them have verified that their ID was received yet on the client side and sent back a message saying, hey, we received it. And while that's the case, for each threaded client, so for this is still client 1 we're dealing with, if there's data ready to be received from the client side, meaning that we are receiving verification that the client side did receive that ID, and num is equal to 0, then we check to see if the integer of the received message from the connection is equal to 1. if it is equal to 1, then self.verified ID received is plus equal to 1, and initially self.verified ID received is 0. So that means for client 1, it's going to receive this integer from the client side after sending the ID out to it. And then we say self-verified ID received is now 0 plus 1, which is 1. Then we set num to 1 so that it won't run again on this thread. But then when the second client thread starts, it will enter into this while because verified ID received is still equal to 1. Then it will say if ready is equal to 0 and num is equal to 0, which it will be on that thread. And then it'll say if int con decode is equal to 1, which I'm guessing we just send back 1 for each time. So then at this point, self.verified ID received is plus equal to 1 again, which is 1 plus 1. So now self-verified ID is equal to 2. Num is set to 1 so that this won't run again, and we could actually just use break instead of... We could actually just use break, couldn't we? But, so, long story short, at this point, both of the clients have been connected. So if this is the thread, if this is, and keep in mind, this will cause client 1 thread to hang, to be blocked, right, stuck on this while loop until that second client connects. So it won't go to the next step of the game, which is the beginning of the data transfer. Because how can you do data transfer between both, between the server and the two clients if you don't have both clients connected? So, makes you feel very smart when you talk like this. Now, or later. Now is better. That means we can assign other con from the perspective of client 1 thread at this point, because at this point both clients are connected, which means self con 2 should not equal none. And what we can do to verify this is say if other con is not equal to none, print other con not equal none, and we'll just put all caps so we can see it. Other con, and we'll just put a bunch of stars so we'll be able to see it. And there we go. 24 added for testing purposes only during debugging. Okay. So now this is, we can put a div right there, and I'll put below 9, 5, 10, 24 assigns other con equal to self.con 2, because if we were to assign it earlier on from client 1's perspective self.con2 is still equal to none. We can't assign other con until client 2 has been connected, which is at this point, which is verified at this point. Okay, yeah, that's pretty straightforward. Now, ooh, well, actually, I need to specify this. I need to say, if current client dot ID is equal to 1, because we don't want to do this for, we don't want to do that for if current client ID is equal to 2, because if current client ID is equal to 2, we can assign other con right here, and there shouldn't be any issue with it. But anyway, so now let's some string client. What am I doing, man? I wanted to add another comment. Oh yeah, that's right here. Okay, so I want to put a little bit more. Let me say comment. I mean, that is descriptive. I just put note that from client 1's perspective, the while loop is blocking until client 2 has also connected. This ensures client 1 won't attempt to begin data exchange with client 2 because client 2 is not connected yet. Yeah, just a little clarification for that. And I'll put starts at 0 plus equal 1 for each thread client to verify. Yeah, there we go. Okay, so that's a lot more descriptive, and we can verify, and actually we don't need that where we put, let's see, where do we put it? This right here. If other con is not equal to none, we don't need to do that now because we know other con is not going to be none, or it shouldn't be anyway. So now let's go ahead and start the server. Now we're running client. We're going to run the other client. Okay, maybe we have another bug. Okay, so it's verifying for both clients that other client is not equal to none, which is good. That's what we want. Now, something's gone wrong. What's the problem? Okay, so let's read our logs to see what is going on here. Okay, so we start the server. We get other con is not equal to none. Other con is not equal to none. Okay, we get that twice. I'm guessing, well, that would be once for each. Well, that's not necessarily for each. Other con is equal to none. So really, I want to say, and current client.id is equal to 1, because we only want to run this so we want to check if current ID is equal to 1 and other con is not equal to none. Then we want to print other con not equal to none, because this could very well be printing twice from client too. You see what I'm saying? So now we specified. So let's try this again, and let's just make sure that before we move on, that we have indeed fixed that issue. And looks like we're still waiting for the other clients, and now we can kill the script. And alright, let's go to the top. So we do get that printout, which verifies that other con is not equal to none, which is good. That's what we want. And then we have an exception. Is this when I went to go close it? Waiting on the clear, waiting on the player to join, create over that game started the draw, and then accepting time. Okay. A little bit of debugging here. Let's try to figure this out. Okay. What is the problem here? Let's do this again. Okay. Now. Okay. There we go. So we get game state is equal to waiting other player. Then we do create double deck. Then we get current light received, progression text, waiting for the other player to join the server. Well, wait a second. Why would this be received? Okay, I see. That's the dynamic. Here we go. Alright, so this is for receive change attribute list. Now, I thought waiting other player would come from the server to the client, not that we would be receiving it from the client. But that is indeed what this shows, that the threaded client server side for client 1 is receiving the progression text waiting other, game state waiting other player. So let me search for this and see where this is assigned. So let's do Control F, this is gonna be in progression, I believe. Maybe. Oh, it's gonna be with. How about this? We'll just do waiting other player. And even better, we'll do Control Shift F. How about that? Now, this is checks. Wait a second. Okay, here we go. That's where it's assigned. That's where it's checked, and then it's assigned. Okay, so it's assigned this from the. This is assigned from the. Wait, what function is this in a function? Or no, this is literally just in the client. Oh, okay. Okay, so this is. It does get assigned on the client side. I'm just thinking about this for a second. Should we assign this from the client side or from the server side? Okay, and then let's just roll with it, and then it sends. So that is correct, though. That is. I thought it was maybe double, like circularly sending something. I just wanted to make sure of that. Okay, so then we run setup, which creates a double deck. Okay, and then we run on the. Oh no, this is actually server side. So let me go back to the server. I'm a little bit scattered here. Okay, so setup gets run right here. And this happens. Okay, so it listens and it this blocks this thread, the main thread, and then well, wait a second, hold on. So no, we're actually running setup from line 19. Oh, no. That's the printout from... Yeah, I'm tripping. I'm rusty here. That's printing... Okay, I see now. It's printing from the setup function. Okay. So that's the first thing to happen is setup right here. And that's really stemming from this. Alright. Then because this is 3 different threads, remember we got the main thread, this is the main thread. So this is happening from main thread. And You know, I could actually specify that in the logging. I'm not really worried about it though. I should be able to decipher that without that. Anyway, so we run setup in the main thread while the other two threads are connecting. In the meantime, thread 2 is connected to client 1, and that's when we enter threaded client, we assign these values, then we do our verified thing, which means the second thread and the third thread hang at this point in time. Then, whenever the client actually connects on the client side, it gets that client ID right here. It checks the client ID, and then it assigns these various values based on the client ID. And it sets this game state, so that's what gets sent over. And in the meantime, on threaded client 1, it's still finishing running the setup file, which it's creating the double deck, and in the meantime, client 1 then changes the progression text to waiting for other player to join the server, which indeed is correct. Okay, now I just want to pause right there and ask, is that where we want that to be executed from? Well, yeah, because we could set it to that on the server side, but it does seem more reasonable to set it on the client side. Because until the client this is fine. We set it to waiting other player on the client side, and then once the second client connects on the server side, it changes the game state for each client to the draw 1 or whatever the next stage game state would be. So yeah, that's actually that's fine. All right. Now, then in line 352 in the main thread, server.gamestarted is equal to true. So let's go down there. So in the main thread, we're down here. We ran setup. Game started was hanging at false, but then eventually C1 was online and C2 became online, and those are changed to online way up here. Somewhere up here. Okay, yeah, up here for start accepting clients. So yeah, this is actually still running. This start accepting clients, and this part is a little bit confusing to me because how is start accepting clients recalled again? because initially we call start accepting clients after bind the server listen, but we only call it once. So if we say server start accepting clients is called from the main thread, and then we go to start accepting clients, it's going to enter into this as long as both clients are offline, or either client, as long as a client, at least one, is offline. It then accepts that incoming connection. So even though we call this once, it goes into this function for the first client, accepts it, assigns the con and the address, and then it says if self current player n is equal to 1, so for the first time, then it changes C1 online to true. Okay. And then well, right before that, it starts the new thread. So now we have another thread, the client thread. So this was all happening in the main thread, but this line right here starts the new thread. And the main thread is done with this function. So the threaded client one starts, but if you go back down to the main thread, we don't recall start accepting clients. It already has been called, and as you can see, before the let's see, and then try while server game starting is equal to false. So the only thing that gets called again after we run setup, so we run setup, and you can see that before setup finishes, we're receiving data from client 1, but then client 2 connects. But we never actually recall this start accepting client function, which means that the start accepting clients, there's something in it that I think it has to do with listen. Since we ran listen is like non-blocking on the main thread. Basically, like it keeps checking again for a new connection without having a while loop. Like, it doesn't block. See what I'm saying? Like, a while loop blocks, but the listen doesn't block. It allows the other client, it allows the main thread to continue to do what it's doing further down the line while still listening for that second client. And then whenever that second client does finally show up, that's when through this listen somehow, start accepting clients is run again, because it has to be run again. But we don't, the place that start accepting clients is called is I don't really fully understand how start accepting clients runs twice. Let me see something. I want to see if start accepting clients is run twice, because this has kind of been confusing to me ever since I started this. Like, I know that it works, but I don't know how it works. You understand? I don't know exactly how it does what it does, but it does it. So you can see it's saying waiting other player to join. Now, start accepting clients is run, then set up so it's not run twice. Or, oh, it's just still waiting. That's all. It's not, it doesn't get run twice. It just is hanging. It is blocking. I'm just misunderstanding how this works. Yeah, so this is blocking like a normal while loop. Because this is, as long as C1 is online, or C2, as long as C1 is offline, or C2 is offline, which means if any client is not online, it's going to stay in this while loop. So that was where I misunderstood. It's not going to break out of this while loop until both clients have been connected. So I just misunderstood that. There wasn't some like magic non-blocking while loop that I was like thinking there was some special, code in the listen function or whatever that was, causing it to keep going and then wait for the other client and let the main thread keep going. It was actually blocking the main thread. As you can see, setup doesn't run until start accepting clients is done. Well, you don't necessarily know that it's done, but if I were to put a log at the end of start accepting clients, you would see that setup wouldn't initiate until we saw the end log from start accepting clients. So now I understand that better. So both clients get connected. And then, let's see. So after that, we do Pygame display set mode. I don't know if I actually need to do that, but anyway, I'm gonna put a comment right here, actually. Okay. now we run setup, and then we try while server game started is equal to false. So actually though, if what I just said is true about the start accepting clients thing, which seems to be true and will certainly have to be true, considering the logic of that while loop and the fact that while loops block, and that this is called from the main thread, and this is also from the main thread. That means once this line was done, that means both clients had been connected, which also means that at this point in time, server.gamestarted should not ever be false. Isn't that right? So like this seems to be like redundant. While server.gamestarted is equal to false, if server.c1 online, and I can put right here, blocks via while loop until both clients are online. And let me just triple check that, make sure I worded that correctly. I don't want to be sloppy in my language. And indeed, yes. Yeah, while C1 online is equal to false or C2 online, yep, and then it connects and then it changes the C1 online to true and then C2 online to true. So this blocks until both clients have connected. Become online. Okay. Yeah. Yep, that's... Alright. So that means no matter what... Let me read this. While debugging DTM logs suggested it may be crashing before we can get server game started equal to true. Notice that we did not have a try except for this while loop so that it doesn't break out of the while loop so that it can then print out all of the logs. Since we need the logs, add a try except for this here. Okay, because when we do Control C as a keyboard interrupt or whatever, that triggers the except, which triggers the logs. Let's put necessary for logging. Necessary to trigger logs for killing script via keyboard interrupt. I always forget how to spell necessary. Isn't it two C's? Necessary, yeah. Isn't it? I always forget. Anyway, so I'm looking at this code and I'm seeing this while server game started is equal to false. But it should never get to this point until they're so how about this? We'll do this for testing. We'll say if server.cl1.online is equal to true. I'll just pretty much copy this line right here. We'll put in servers, you go true, print, both online after start accepting clients. Okay. So let's run this again. And let's see what we get here. So let's kill the script. Let's see. So we just send a game state waiting for a player, waiting for a player to join. Oh, the print, it should actually be further up. Yeah, both online after start accepting clients. Okay, so that means, indeed, we, that would insinuate that, this logic is, like, redundant. So... let's see. Wait a second. Is this actually necessary, though? I'm sorry. I'm a little rusty on this part. I don't have to apologize, but, I'm just looking at this. I'm trying to fix this logic right here, because, you know, I rearranged everything during DTM. I didn't mess with this part, though, but this is a part that hadn't been, improved in a really long time, and, I had modified it a lot during like debugging and stuff, trying different solutions for these bugs I was having, not realizing that most of it was due to the data transfer issues. So I was trying all kind of weird stuff, you know, pointing the finger in the wrong places. And what I'm noticing here is, I put that while bugging DTM log suggested it may be crashing before we can get server game started is equal to true. Notice that we did not have a try except for this while loop, so that it doesn't break out of the while loop, so that it can then print out. Okay. Okay, so it was... So if I were to remove this try except, would it not print the logs out in certain instances? Like, so if I do a keyboard interrupt, while it's in a while loop, does that break out of the while loop? I don't understand. I'm realizing this. I don't fully understand what happens when I do a keyboard interrupt. Let's see. So you can see right here, whenever I do Control-C to kill the script, it's considered a keyboard interrupt. But you can see that it continues after I interrupt it. It doesn't actually, like, immediately stop the processing of the script. It continues to go through the entire script until the very last line, until we get to OS exit. And it's actually break time, so I'm gonna go get a little bit of coffee. Yay, coffee, because I'm tired. I slept like 6 hours last night, which isn't... It's not great. I'm just gonna be honest. I was pissed. I laid down. I had 7.5 hours. Like when I laid down, when I was like ready, I had taken my sleeping medicine, and I was ready to fall asleep with exactly 7.5 hours. I remember looking at my clock, and I was like, yeah, cool. So if I fall asleep in like 10 minutes, I get over 7 hours of sleep. Turns out, couldn't fall asleep. It took me like an hour, maybe more, to actually fall asleep. So I didn't get the most sleep last night. So I'm a little bit tired today. Yeah, so I'll be back. Coffee break. Don't let friends drink coffee alone. Okay, quick little break. I'm back. Try to shorten up my breaks a little bit because I was getting a little long with my breaks the other day, so I gotta, you know, cut back on these today to make up for it. I really like to take like really just a 5-minute break every hour. Going any more than that is a little high. Okay, so now I understand from talking through this that keyboard interrupt so if I were to kill the script without a keyboard interrupt, without a try and accept to catch the keyboard interrupt, which is an exception, then does that mean when I did a keyboard interrupt, it would just like continue to be trapped in that while loop? You know what I mean? Or like, okay. So, I think if I were to do a keyboard interrupt from the while loop, now I understand, okay. If I were to do the keyboard interrupt from a while loop without a try and accept, that would mean it would try... No, that means once I did the keyboard interrupt, instead of catching the exception and then continuing the script despite the exception occurring, it would instead not continue processing the script and would immediately crash. So if I did this while server, whatever while loop, keyboard interrupt from within the while loop, it's just gonna stop immediately. It's not gonna go another line. It's gonna stop at whatever point I did the keyboard interrupt. It's done. Nothing else in the file is gonna happen. So I added the try except so that whenever I do a keyboard interrupt, or if there's any other sort of error that occurs, that guarantees that we continue to process the script, which eventually, right here, will print out all of our logs, of which, one of which is the actual exception, because that's just how I have my logging set up, to where it shows me all of my traceback, and all that stuff. Anyway, I just had to refresh myself on that, and maybe you learned something from it too. So yeah, if you want to print out logs in the manner that I do, after an exception occurs, you have to have a try and accept for that to happen. Otherwise, whenever the error occurs, your script immediately crashes. Okay, so what I'm questioning now is this logic. Basically, I'm wondering why I need to do this? Why do I need to check? Why do I need to run this section at all? Because as far as I understand it, at this point in the game, server C1 online and C2 online should both be true. And we verify that by the fact that start accepting client blocks until both of them are online, which means both of these would be true at that point. So, is there some reason to use game started? Let's do a Control-Shift-F on game started. Okay. So game started is equal to true. Okay, so we do use game started here. But again, let's see, this is inside of threaded client. Okay. So we may need the game started attribute for this purpose, because if we didn't have this check right here and we just immediately assumed that the game had been started at this point, then that would set the attribute of the game state to other player disconnected. But if this would ever happened, because this is all within a while loop, and this is darkened out now because we previously had try and accept, and I have since removed them because I wanted to rework it to make sure I put the the try and accept in the right places, and that I was just doing it correctly. So, in light of this being necessary, because the logic here is that this while loop, which is in the threaded client, okay, no, here, it's another, this is actually another instance, I think, of redundant logic, because I was fuzzy on this before, but since I refresh myself, I know that at this point, after this, once this while loop is done running, and this applies to both client threads, at that point, that means both clients have been connected. Until both clients have connected, this while loop will block on the threaded client, on the on the threaded, it will block this thread for each thread. There's two of them, which means that once we got down to this section, right here, which, if we got to this section, it means that there was some sort of error that happened in the main while loop for the threaded client, which is the data transfer while loop. It continuously runs throughout the game for each client, receiving and sending data accordingly based on all the changes that are made, server side and client side. So if both of the clients are connected after this point, doesn't that mean that game started would be true? Or doesn't that mean that the logic that game started equaling true entails be applied, be the case rather, which means we wouldn't need to check to see if game started is equal to true. Because yeah, I'm pretty certain of that. I'm pretty certain that saying if self game started is equal to true is the same thing as saying if both clients have been connected. At one point in time, both of the clients got connected. Therefore, that means we can that would have changed self game started equal to true. So I think what I'll do is I can remove this check right here. So we're going to remove this. I'm looking at all this. See, I got a bunch of threads going on in my mind right now. There's a lot of different trains of thought. To improve all this logic, this is what happens. You will look at a lot of different things before you change anything. You will look at a lot of 10 different things and you will think it through. And that's the way to go. I've learned to talk it out and to go slowly and to think it through. And as I'm looking at this, I'm also realizing that, at least I think that since this here, this connection dot close is run here, and then we say self start accepting clients from this separate thread. And this thread immediately terminates or ends right after. Well, okay, actually, no, I don't, so, I think this actually is good logic, because I don't know about this connection not close. I don't know what that actually means. Like, I know to start the thread, you need the connection to start, or rather, let's see, at the beginning of it. Let's see, let's go, okay, here we go. Threading.thread, target equals self.threaded client. And then we say new thread dot start. But that's, the thread is separate from the connection. So we have this new thread which takes in the connection, and then this connection is basically just a link between the server and the client, okay? And whenever the player disconnects, it ends the while loop because it will throw some sort of like disconnection error or whatever. And granted that we have a try except here, which we currently don't, but will add in a second. Then it will go down here and it would then close the connection. But my question, I guess, then is, if we had a connection-based error, would that not close the client in and of itself? Or do we have to say connection.close right here explicitly for that client, that connection to actually close? See what I mean? See, and I don't know the answer to that. I'm not sure. I'll save that for another time, I guess. Okay, now, concerning the next line, start accepting clients. This I think is actually fine because we still have the thread active as long as we're running lines in this thread, like, and until we either explicitly stop the thread by calling thread stop or whatever that is, end, stop, whatever, or I think it also ends automatically whenever you're done running all the code from the thread, like it's finished. So if I open up a thread and I want to print hello world 20 times, I do a for, in range of 20, print out hello world 20 times. Once that's done, that thread is no longer going to exist. It's going to shut down. At least I'm pretty sure that's how it works. Let me ask Python. Let me ask Gemini. In Python, when you finish running all the code in a thread, does the thread terminate? When you finish running all the code in a thread, does the thread terminate? Yes, in Python, when the entire program execution finishes, all threads, including those that haven't been completed their tasks, will be terminated. Oh, okay, no. In Python, if a non-main thread finishes running all the code in its thread function, does that thread terminate? When a non-main thread finishes executing the code in its function, its behavior depends on whether it is a daemon thread or a non-daemon thread. Non-daemon thread. If the non-main thread is not marked as a daemon thread, which is the default behavior, then it will not terminate just because it has finished its specific function. As long as the main thread is still alive and there are other non-daemon threads still running, the finished non-daemon thread will remain alive even if it has no further tasks to perform. So if it is not a daemon thread, then it will not terminate when it's finished. So as long as the main thread is still alive and there are other non-daemon threads still running, the finished non-daemon thread will remain alive even if it has no further tasks to perform. This is because the main thread waits for all non-daemon threads to finish before exiting. It's because the main thread waits for all non-daemon threads to finish. Okay, yeah, I understand that, but I mean, I get that. That seems irrelevant. Anyway, if the non-main thread is marked as a daemon thread using the setDaemonTrue method, then it might be terminated when it finishes its function, provided no other non-daemon threads are alive. Daemon threads are meant for background tasks that are not critical to the program's overall execution. Their termination doesn't affect the program's main flow. However, if there are still other non-daemon threads running after a daemon thread finishes, the daemon thread can be forcefully terminated when the main thread exits. Okay, that's kind of confusing. Non-daemon thread stays alive until main thread and all other non-daemon thread finish. A daemon thread may be terminated if no other non-daemon threads are alive. Otherwise, stays alive until the main thread exits. Okay. Important consideration. Non-daemon threads can block program exit. If you have non-daemon threads that never terminate or get stuck in an infinite loop, they can prevent the program from exiting cleanly. Daemon threads don't guarantee completion. Even if a daemon thread finishes its designated task, it might still be terminated before it has a chance to... Daemon threads don't guarantee completion. Even if a daemon thread finishes its designated task, the daemon thread finishes its designated task, it might still be terminated before it has a chance to perform cleanup operations if the main thread exits. Thread safety. If your program relies on multiple threads accessing shared resources, you still need to implement mechanisms like locks or semaphores to ensure thread safety and avoid race conditions, even if you're using daemon threads. Okay. Use non-daemon threads for tasks that are essential to the program's completion. Use non-daemon threads for tasks that are essential to the program's completion. Use daemon threads for background tasks that can be terminated if necessary. Okay, so really my question is then, if I close the connection, I mean, my logic in this function, I was thinking I could just use the same thread. I don't have to make a new thread. But if I were to do that, I would have to change all this logic. Because, like... I was thinking, so I could use the same thread, or I could do it how I currently have it coded, to where, well, and actually I think I just learned that that thread is not actually being killed. So even if a connection is lost and then we reconnect, instead of the old thread being killed and then a new thread being started, which is what I thought happened, seemed to suggest that this initial thread would still be alive and not doing anything. So I don't know if it would negatively affect the performance. I don't know if it would have a performance impact, but I mean, it seems like it would. It would be a good idea to kill it, right? Because obviously less threads is better, you know. So I think then, I don't know exactly what I should do. Should I just make it to where it uses the same thread? If I use the same thread though, no, I'm not going to change that. I'm going to make a new thread, but I do want to make sure this thread is killed, is terminated. So, let's see. Python, how do we ensure that a thread is killed? Okay. Here's what I'm gonna do. I'm gonna add this in things to do because I want to get back to the logic that I was messing with, and this is like a whole little section in and of itself of improvement that I can make, and I'll just call this threading improvement. Improve logic associated with threads when they are ending, i.e. whenever a player is DC'd, etc., so that one, the thread is terminated, needs to be checked to see if is alive. Yeah, I'm like, is there another reason? Improve logic associated with threads when they are ending so that the thread is terminated. Doesn't this imply having a different variable name for each subsequently created thread, so we can call is alive on the thread by namespace. Would have to add a logic for whenever thread is created, give it a dynamic created name. Would probably have to refer to the thread from the server, from the main thread, to check if alive and to terminate. And let me see. In Python, how much overhead is associated with creating a new thread? The overhead associated with creating a new thread in Python is generally considered to be relatively low compared to the execution time of the tasks you plan to run within the thread. However, it is not entirely negligible, and it's important to consider in the context of your specific use case. Yeah, considering that we're not going to be, like, always, like, it's a pretty rare occurrence that a player disconnects. You know, that little quarter of a second or whatever it might take versus, like, restructuring the entire logic of that whole section to, you know, to gain back a quarter of a second. It's just not a trade-off I'm willing to make, you know what I'm saying? Like, if you're creating a thread every 10 seconds, or second, yeah, it would probably make sense then. But if you might not ever be creating a new thread, other than when it's initially created, like, yeah, I'm not gonna rework the logic. But anyway, it's good to know that, like, just to know. It's good to know. Knowledge is power. Resource allocation. When you create a new thread, the operating system needs to allocate resources for it, such as a stack, thread control block, and potentially CPU. When you create a new thread, let's actually read it and, like, read it. You know what I mean? The operating system needs to allocate resources for it, such as a stack, a thread control block, and potentially CPU registers. This allocation process contributes to the overhead. And then 2 is system calls. Creating a thread involves system calls to the operating system kernel. These calls incur some overhead for context switching between the main thread and the kernel. Okay. And then the global interpreter log interaction. In Python's implementation, CPython, a single thread can execute bytecode at a time due to the global interpreter log. While creating a new thread itself isn't affected by the global interpreter log, if your threads involve significant execution of Python bytecode within the thread function, there might be some overhead due to context switching between threads at the bytecode level. Okay, yeah, that's more of, like, not overhead associated with creating it. That's more of, like, using it. Factors affecting perceived overhead. Task length. If the tasks you plan to run within the threads are relatively long running, the tasks you plan to run within the threads are relatively long running, there becomes less significant compared to the logs used now. Alright, yeah, I already know all this. This is, like, extra. Okay. So, alright. I'm cool. I'm cool with the decision I made. We're just gonna have one thread. We're not gonna rework that. Okay, so back to this. Got sidetracked, but it's all part of the process. I need to learn all this stuff and to have a solid grasp on it to improve on the entire design. How can you improve on a design that you don't fully understand? So, anyway, when we deviated, we were actually curious about this line, and then, okay, now moving on to this one. Well, and I already added this to things to do, and that was threading improvement. So we'll take care of that. That's gonna come. But the current state of where if we were to have an exception, we're gonna add in a try and except right here for this while loop. In the case of an exception, it's gonna enter into this section, and then it's going to check if game started is equal to true. But remember we were saying we're pretty sure that it would already be, like, we don't have to check that. That would already be the case, like, guaranteed, by proxy of the fact that it had already finished this section right here. So it's redundant. So we could just nix this. Yeah, because it's not going to let you... Yeah, like, I already know this. It's not going to let you... Yeah. Yep, I'm, like, positive. So let's get rid of this line. Stupid pop-ups, man. Go away. Okay. Now we will do this, and then else, we don't need this else anymore. Now this is gonna be except. Okay, and actually it's gonna go right here. Well, I'm sorry, this is wrong. What? Okay. Hold up. Alright. Here's how we need to do this. Trying to think, where should we put our try? Where should we start our try and our accept? Because we want the try and accept to be in the proper location. We don't want to just, you know, throw them wherever. We need it to be in the right spot, which is the whole reason why I got rid of the previous one. So let's think about this. The requirement would be that whenever we hit this exception right here, that means that the player has disconnected. And I guess what we should do, well, what exception would be triggered by the player being disconnected? Well, let me ask, because I know there's a couple. There's connection reset error, and then there's another one. There's connection. Let me see. In Python, what are the different connection errors called? Connection error. Okay. Connection errors. This is the base class for several connection-related exceptions. It doesn't provide specific details about the error, but it serves as a general indication that a connection issue has occurred. Connection refused. This error is raised when a connection attempt is rejected by the remote host. Possible reasons include the remote host is not running a service that listens on the specified port. There's a firewall blocking the connection on the remote host. The specified port number is invalid. Connection reset error. This error indicates that an existing connection was forcibly terminated by the remote host. This could happen due to the remote process unexpectedly crashing, the remote host actively resetting the connection, network issues causing the connection to drop. And then connection aborted error. This error signifies that the connection was aborted while data was being transmitted. This might occur due to an unexpected termination on either the local or remote machine, network timeouts, or transmission errors. And, you know, that's something that I'm eventually going to have to add in to account for, is like network issues that don't exist currently because I've been doing everything on my local machine. But like when you're actually dealing with like the real world internet and, you know, other problems, like, you know, we have to establish that's another little section of the game that's gonna have to be coded that I didn't really think about. Anyway, we'll cross that bridge when we get to it. This error signifies that okay, timeout errors, various exceptions, several exceptions like socket.timeout, timeout error, depending on the library, can be raised when connection attempts or data transfer operations exceeded a specific timeout period. This indicates that the expected response to data transfer couldn't be completed within the allotted time. Other potential errors: OS error. The broad exception can encompass various operating system related errors during cycle creation or interaction. potentially related to network issues or resource limitations. And then address error. This error might occur if you provide an invalid network address. For example, an unresolvable hostname or an address that doesn't follow the expected format. It is essential to implement proper error handling mechanism in your network code using try-except blocks to catch these exceptions. The specific error message and exception type can provide valuable clues about the nature of the connection problem. You can use network tools like ping or trace route to diagnose potential network connectivity issues between your machine and the remote host. So try sock, create a socket, sock connect, okay. Except connection refused error, connection reset error, connection or timeout error. Print connection error E. Okay. And then accept exception as E. Catch other potential errors, and then finally always close the socket. Okay, so that is where we... Oh, see, that's another thing we don't have implemented is closing the socket whenever... So currently, whenever we open a socket, whenever we create a socket, if that threaded client becomes disconnected and terminated, we're not actually closing the socket. Which I guess is a security issue. Let's see. So always close the socket, sock.close. Let us add that in, and we're gonna change this things to do to be, we'll call this networking improvements. Improve logical state of the threads when they are ending. And then I'll put improve various aspects of network security, logic, thread logic, etc. And then this would need to be, and then we'll put ensure sockets are being closed after server side. Or would we also need to do that client side as well? Well, if well, that's a question I need to ask. After connection errors, etc. See, so I'm kind of fuzzy on this. Like, I'm not kind of fuzzy. I just don't know. I'm not educated on this very much. I only have a very basic understanding of networking and all that stuff. And this is how I learn. Like, this is the project that is teaching me all this stuff. Like, this is how I learn through this project. So I don't actually know. I'm guessing like it would be a security issue. If it was server side and you didn't close the socket, then like, you know, the client could worm its way into your system somehow or whatever, or vice versa. If you didn't close it on the client side, the server could worm its way into your system, I suppose. I'm going to ask Gemini that in a second, and we're going to say implement on server side only, or both server and client. So, purpose for this is because and then let's ask Gemini. In Python, why should we always close our sockets? Yes, in Python, you should always close your sockets when you're finished using them. Here's why. 1. Resource management. Sockets are resources associated with your program. Leaving them open unnecessarily can lead to resource depletion, especially if you're creating a large number of connections. Closing a socket releases the resources associated with it, making them available for other uses. 2. Port availability. Open sockets occupy specific ports on your machine. If you don't close sockets, you might run into issues when trying to create new connections that require that same port. Ah, okay. Oh, I wonder if that's why I've had issues with that in the past, because I want to say I had issues with, like, when I was testing whenever a user got disconnected, you know, like making sure that the game was coded to handle that without crashing. And I'm pretty sure I had like issues getting that to work properly, and I'm wondering that may be why. I'm not sure anyway. Anyway, number 3 is clean termination. Closing a socket ensures a clean termination of the connection. It gracefully informs the remote host that the connection is no longer needed and can be closed on their end as well. Okay. Error handling. The close method can sometimes trigger exceptions if there are underlying issues with the connection. By explicitly closing the socket, the method can sometimes trigger exceptions if there are underlying issues. By explicitly closing the socket, you can catch these exceptions and handle them appropriately in your error handling routines. So does that mean that like our sockets automatically close in some instances? How to close sockets. And let me just put this port availability. So I'll copy this because I think this is probably the most, well, I'll just copy all this. Thanks, Gemini. Resource management, port availability. I love me some Gemini. I mean, could I imagine learning the code with just Stack Overflow? That's actually how everyone's done it for, you know. Could carpenters have imagined building a house without a hammer and using a nail gun? Back in my day, you know. The standard way to close a socket in Python is use a close method. Okay. The recommended approach in modern Python is to use socket object as a context manager. This ensures that the socket is automatically closed even if there are exceptions in your code. With socket.socket as my socket. Okay. Socket is automatically closed when the with block exits. Now, why does that happen? What does with implicit, like, what does it with imply that causes that to happen? With statement ensures proper closing even in case of exceptions. Python, what is the with statement? With statement. The with statement Python is a versatile tool for managing resources and ensuring proper cleanup. It provides a concise and elegant way to execute code blocks while guaranteeing that resources are released or closed correctly, even if exceptions occur. Here's a breakdown of the key aspects of the with. With context matter expression as variable name. Code block be executed with context manager expression evaluates to a context manager object. Context managers are classes or objects that provide methods for initializing and finalizing resources. Common examples include files, sockets, locks, and database connections. Okay. So this is something I'll consider. And I'll put this down here. Consider using a context manager, aka the with statement, can't type, which is designed specifically for this purpose. Man. Now let's copy this. So, as clause. You can optionally use the as clause to assign a temporary name to the resource provided by the context manager. This variable can be used within the code block to access the resource. Code block. This is the block of code that will be executed. The resource managed by the context manager is guaranteed to be available within this block. Implicit cleanup. When the code block finishes execution, either normally or due to an exception, the context manager's exit method is automatically invoked. This method is responsible for cleaning up and releasing the associated resources. Files, sockets, locks, and database connections. Improve readability. The with statement makes your code cleaner and more readable by keeping resource management logic separate from the main code block. Reduce boilerplate. It eliminates the need for explicit try finally blocks for resource manager, reducing boilerplate code. Okay. Guaranteed cleanup. Ensures that resources are always properly closed or released even if exceptions occur within the code block. This prevents resource leaks and potential errors. So it's basically like a little library. Like it's like a function that has all that logic for, like, you know, closing and all the related exception handling built into it. Example, without with, you would put file equal open data.txw, write data to the file, try file.write, and put this is some data. Finally, file.close. But with open a file for writing, with open as file.write, no need to explicit finally block, the file is automatically closed. That's cool. Okay. How trustworthy is it though? You know what I mean? The with statement can be nested with multiple context managers. The exit methods will be called in reverse order of their creation. You can use custom classes as context managers by implementing the enter and exit methods to define the resource initialization and cleanup logic. Okay. In conclusion, the with statement is a powerful and convenient tool in Python for managing resources and ensuring proper cleanup. It promotes clean code organization, reduces boilerplate, and prevents resource leaks, making it a valuable addition to your Python programming toolkit. Okay, cool. So I will did I copy that? No. Let me see. You know, I think my favorite part of coding is actually learning. Learning new things. It's actually my favorite thing. Like asking Gemini questions and learning. It's fun. Okay, 2 hours, 20 minutes, so yeah, it's time for break. I'll be back in like 5-10 minutes.
Also been detected in mammals, with cattle herds across 4 states becoming infected in recent weeks. And on Monday, federal health officials announced that a dairy worker in Texas caught the virus. Dr. Suresh Kuchipudi, a bird flu researcher in Pittsburgh, said we are now, quote, getting dangerously close to this virus potentially causing a pandemic. He noted that H5N1 has already been detected in species across the world, and said, quote, I think this is a virus that has the greatest pandemic threat that is playing out in plain sight and globally present. The World Health Organization estimates that about 50...
Okay, I'm back. I had to use the potty, you know what I mean? That coffee. The coffee did it. Blame the coffee. Anyway, not to desktop we go back to here. Alright, so we were figuring out what our next steps are going to be via discussion with my good old pal Gemini, and Gemini has some really solid insights for me, which include using width to ensure that my sockets are closed properly, etc., etc. So anyway, we removed this line, the if and then else, because we determined that we would that was redundant logic. So I think, yeah, right now the next step is implementing this try and except. But I did touch on this. I wanted to finish up my exposition of this line right here. So we run this start accepting clients from the let me just put this right here so I don't forget. Yeah, I'll put that right there. Okay. So what happens is when there's a connection error, we will, and I can actually just go ahead and add this. We'll put except, and we'll put various connection errors. See Gemini for them. So this is going to be our accept, and then all this is going to occur within the kind of all over the place, you know, like, but that's how coding is. Like, it's just, well, at least that's how it is for me. Some people are a lot more structured than me. It can be a disadvantage, but it can also be an advantage. It depends. So after this point, and I'll just put, at this point, both clients are verified to be connected online. So then we'll put add try here for connection error, exceptions, and other exceptions. So then, yeah, we also want to add in, we have this except various connection and we don't have to do except as E or whatever, I don't think, because we already, this logger function method rather, like incorporates the printing of the of that information, I think. But what we would want to do is, okay, so then we would want another except, but this would be except other exceptions, non-connection errors, and in this case we would want to log let's put this is below logging line correct? Will it incorporate proper exception info? I'm not sure. Okay, and then this right here, we're gonna want to add in add log, which includes pertinent exception info. And then either way, like regardless of, you know, which exception is triggered, we will run this section, which closes the connection and then starts accepting new clients. And as I begin to touch on and keep getting like sidetracked from, we will, in the case of an error, an exception, this accept will catch it, put out a log associated with it, and then this line will run. Since we're no longer bound by this while loop, this connection close will run, and then we'll initiate self.start accepting clients, which will keep this thread alive, or at least active, by running self.start accepting clients. So now we have this true added, and I know I'm literally like multi-threading, but I'm not very good at it. Not as good as computers, that's for sure. But now we have this try, which will try to execute all this stuff, and I want to make sure that re-implemented this necessary try except block to catch connection and other errors for various reasons, logging player DC notifications, and then what else? Restarting, accepting new connection. Okay, yeah. So this try is going to handle all this. If something goes wrong, let me make sure I got this on the right indentation. I didn't really look very good. Try, and then it's going to go, yep, accept various connection errors, and then other. And like I said, for self.start accepting clients, let's go up to where that's defined, finally. And what's going to happen is we're going to enter into this, and it's going to enter into this while loop, because at this point, well, okay, so we need to make sure that at this point C1 online is equal to false, or C2 online is equal to false. So where is that changed to false? Did we remove the code which did that? Let's do Control-Shift-F for online, and let's see what... so that's the initial setting of it. This is the check for it. This checks for it, checks for it. Okay, but where do we set it to false? Okay, here we go. Right, okay, I just wanted to make sure we did have that implemented, so it's going to set that to false. Yeah, cool. Alright, so that's going to work. So then it's going to enter into this try, and it's going to it's going to block in that thread from which the client had disconnected due to whatever reason, and it's going to wait for a new client to make a connection. Once the client makes that connection, they're going to accept the connection. We're going to assign this data. We're going to enter into this else right here for subsequent connections where player DCs determines which connection to assign a client to, etc., etc. And then let's see, subadder 1 is not equal to subadder 2. Okay, I got you. This is for, we'll put let me do this a little more proper. I'll put below section comment added 5, 10, 24. And this handles for the case in which actually, you know, even better, in a more shortened way. Try to be less wordy here. If self-adder 1 is not equal to self-adder 2. So this is if the game isn't being played locally from one machine IP address. And then this is if the game is being played from oh wait, is it the other way around? Hold on. If self-adder 1 is not equal to self-adder 2. No, that means if the yeah, if the address if they're not the same addresses. If address 1 is not the same as address 2, that means you're not being played. The game isn't being played locally. If the game, so I don't like the way I worded that. This is can be a little bit deceptive if you don't read the not part. So this is if the game is being played locally, and then this is if the game is being played from 2 different machines' IPs. Yeah, so that's a little more explicit and easier to differentiate between, and it's cleaner. So yeah, that's good. So then it will assign this information, and then it will start this new thread. But here's what I was noticing is it's starting a new thread from the non-main thread. So you got the main thread, then you have client 1 thread, then you have client 2 thread. So you got these 3 threads. client 1 thread, let's just say in this case, client 1 thread disconnected. He had a connection issue. So he's disconnected, but this thread, see right here, see him? He's still, the thread is still alive. Thread is still alive. But from that thread, we're going to create another thread. So now you got 4 threads. The main thread, the old client 1 thread, the new client 1 thread, and then client 2 thread. So what we need to do is, after we create this new thread, we need to make sure that this old thread gets closed. So then we only have those 3 threads again. And so basically what I am suggesting is that we would probably need to dynamically assign the name the name of these threads so that we can kill them, because I don't know how you would know which thread is which if you if they all were assigned to just new thread. So I think what we would have to do would be to, maybe we would have 3 different threads as attributes of the server class, or rather 2, because the main thread doesn't need to ever be killed. We don't mess with the main thread. So we would have thread 1 and then thread 2. And basically, whenever we create this new thread, we will check and say if so we want to know if self.current player int is equal to 1, then we would say we could actually do it under it. We could say new thread. We would say self.thread1 equals new thread, and then elif, whoops, elif self.current player int is equal to 2, because it will always be either 1 or 2. Then self.current player n is equal to 1, self.thread1 equals new thread, elif self.current player n is equal to 2, self.thread1 equals new thread. Nope, self.thread2 equals new thread. And we would then start the new thread, and this would Well, then we would have to add in the killing of the thread, because okay, but I don't know if you can kill the thread. You can't kill a thread from the thread. Like, if you kill a thread before you start the new thread, well, I guess you could kill the thread from the thread, if you can kill the thread from the thread, as long as you killed the thread after you created the new thread. See what I'm saying? So you create a new thread, and then it's like having a baby, and then you die. Like, you can't die before you have the baby. You have to have the baby first, and then you can die, which would be terrible. But, terrible analogy, but you get the point. So, we would create the new thread, and alright, I'm just trying to think of the right way to structure this. Because what we're... Okay, I think I know what I could do. An easy way to do this would be to say, if self.currentPlayerIn is equal to 1, then we would say... Okay, let me think about this. I'm crashing. Drink some water. I'm getting a little sleepy. So, rule number 1, we can't kill the old thread until after the new thread is made. So we would have to put it below this line right here. And then we would have to do it from within this if or elif, because we wouldn't know which thread to kill, right? But the question is, here's what we do. We would say if okay, well, I couldn't do that. I was thinking I could do if self.thread1 is equal to none. That would mean, like, well, actually, I could do the inverse. I could say if self.thread1 is not equal to none, that means if self.thread1 is not equal to none, because initially it would be none, like before anyone connected to it, before it was assigned to a live thread, it would be equal to none. But once it has been assigned to a thread, it will not equal none. Now, that means if we're running this section and the self thread 1 or 2 for that matter is not equal to none, then that means someone has disconnected and is reconnecting. And that means self current player is equal to 1. If self thread is not equal to none, then we want to kill thread 1. We could actually say if self dot thread 1 or how about this? We would do and if self dot thread 1 dot is alive, and I don't know if that's actually how you word that. I've never used is alive before, but if self dot thread is not equal to none and self dot thread 1 is alive, then in this case we would kill the thread. Kill self.thread 1. But then either way, after that, we would then assign self.thread 1 equal to new thread. Yeah, I think that's correct. And then the same thing would apply for thread 2. So we would say if self.thread 2 none and self.thread 2 is alive, kill thread 2, and then we would assign thread 2 equal to the new thread. Why does that word look so weird to me? Thread. 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 Okay, so let's review this. If self.current player, let's start from the top. So it's going to connect, if self connect sum is equal to 1, assigns con and adder, else, which is for subsequent connections whenever a player DCs, determines which con to assign client to. In that case, we check if self adder 1, if it's the game is being played on 2 different machines, then we figure out how to assign the connection to the correct number. And then if it's being played locally, we just see which one is online and which one is not online, because online is changed to false whenever they have their connection error. And then, after all that, we create a new thread, passing in the connection and the current player int. Then we check if current player int is equal to 1. If it is, then we check to see if self.thread1 is not equal to none, meaning that it is equal to whatever connection, whatever thread, you know, has previously it was assigned to, meaning there has already been a thread 1 for a threaded client, and that player disconnected. And we also check to see if self.thread1 is alive. So if self.thread1 is still alive and active, and self.thread1 is not equal to none, because if it was equal to none, that means this is the first time we're assigning the threaded client to thread 1, then in this case we want to make sure we kill that thread that we called this new threaded client function from. So from the new, well, no, I'm sorry. That's the question. Can we actually kill a thread from a thread? So that's the question. I forgot to ask. Can you kill a thread from a thread? Kill a thread from a thread in Python. No, directly killing a thread from another thread in Python is generally not recommended. Can lead to unexpected behavior. Here's why. Limited control. Threads are independent units of execution. A thread doesn't have direct control over the termination of another thread. Okay, so you actually have to call it, or are supposed to call it, from the thread that you're using. Thread safety issue. If a thread tries to modify the state of another thread while it's running, it can lead to race conditions and unpredictable behavior. Killing a thread abruptly might leave resources in. Okay. Here's some thread purchase for coordinating thread termination. Flags, you can use shared variables. A thread can set a flag to indicate that it should terminate, and other threads can periodically check flag and exit grace when necessary. Oh yeah, isn't that, but you just said not to do that. Make your mind up. Okay, Gemini, you kind of gave me a non-answer here. Let's try this. In Python, can I kill a thread? Can I kill X thread from inside X thread? I advise against directly killing a thread from within another thread. It can lead to unpredictable. No, man. No. Python. Can a thread terminate itself? Yes, in Python a thread can terminate itself. Returning from the thread function. The most common way for a thread to terminate itself is by reaching the end of its function and returning. Once the thread function finishes executing all its instructions, the thread itself automatically terminates. Print. Thread started. Time sleep. Somebody's going to print that period. Start. If the thread is not marked as a daemon thread, the default behavior, it will block the main thread from exiting until it terminates itself. If the thread is not marked as a daemon thread, it will block the main thread from exiting until it terminates itself. That's fine. The thread needs to perform cleanup operations, closing files or releasing resources. Before exiting, returning from the thread function is generally the preferred approach. This ensures that the cleanup code is executed before the thread terminates. Thread exit issues. Using thread exit can lead to unexpected behavior in certain situations. And returning from the thread function for termination. A thread in Python can terminate itself by returning from its function, or less ideally by using. Well, you gave me a. You said you said something different before. before you said that non-daemon threads didn't automatically terminate. Well, long story short, I think that I can conclude so I'm just thinking here, if I were to just let it return or whatever, then how sure am I like it would be done? There is no let me think about this for a second. So we have threaded client. So at the end of threaded client, it's gonna try accept. It's gonna close. It's gonna start accepting clients. So let's go back up to start accepting clients, and from there, it would enter into this while. It would run this one time because then it would reconnect that new client or reconnect rather, start that new thread, and after it ran all this, it would then come to the end of this function, and that would be it. It would be out of this while loop, so there would be nothing stopping it, no while loop or anything that it would like be caught in, in the background, and I just would have this thread that was always stuck in this while loop eating up resources. So in this case, if the recommendation is to not explicitly kill the thread and to allow the thread to be naturally terminated, then that's what was recommended, and that is what we should do. So we don't actually need to check if it is alive. Well, of course, if we're operating from that thread, of course it's going to be alive anyway. So this actually just is fine. We don't even need to add any code. Granted that using exit, Python do non-daemon threads terminate by returning from its function. Yes, in Python, non-daemon threads terminate by returning. Why didn't you say that the first time, man? Fuck! Thread lifecycle. When you create a thread using threading.thread, it goes through a lifecycle of states. New, the thread is created but hasn't started execution yet. Running, the thread is actively executing its defined function. Terminated, the thread has finished executing its function and has released its resources. Non-daemon behavior. By default, threads are non-daemonic. What a weird name. Demonic. Demonic threads or non-demonic threads? This means that the main, so default threads are not bad. This means that the main thread of your program will wait for all non-daemon threads to terminate before exiting. So that's the only, thing to note, is that before the main thread can close, all non-daemon threads must be closed, which is basically irrelevant unless our thread that we're talking about, which we're trying to figure out how to handle, did not automatically terminate. Then that would be an issue, and it wouldn't allow us to exit the script. So I think to have a fail-safe security system for once we deploy this, given the array of different, circumstances and variables and weird behavior that would happen in a real-world application when this game was run after it was deployed, then we would probably want to add in, despite the fact that they are supposed to naturally close, terminate, and release the resources, we would want to ensure that they that at the end of their life cycle they are terminated. And we could add in logic like at the end of the server script or whatever that like check for that. Or I think the better option would be, remember we learned about the with statement. I think with would allow us to ensure that those threads would be terminated properly, and it would guarantee that they were terminated so that we would ensure that our main thread would be able to terminate, which I guess in certain instances it would just like not be able to terminate. It would hang or whatever, I guess. So let's use with, to create the thread, which would allow us to, damn, these hours are flying by, bro, I swear. These hours, there's no way that was an hour. That was the fastest hour of my life, I think. Anyway, so let's go ahead, and we actually have 4 more minutes before break. So here's what we'll do. I am going to get rid of this code that I added because we don't actually need it. We don't need this. Okay, so right here, and then how do we use with again? Let's go back up and see our with. Here we go. All right. With open, so okay, so we would say as, so with open, so then in this case we would say with threading.thread. So I'm just going to comment this one out, and then I'm going to put the with threading.thread, I'm guessing this is how you're supposed to do this, as, and we're going to call it new thread, then then we would have to say new thread start. Is that right? I think, so we're going to double comment this out, and I'm going to put the 2, 3, 4, 5, 6 below section commented out or modified 5, 10, 24 above. First 2 lines are replacing the below 2 lines. The subsequent 2 lines to implement with, which will ensure that the thread is releases its resources and properly terminates and guarantees a proper termination of the thread after it is finished executing all of its code. Not 100% sure about the syntax logic associated with therefore leaving the commented out section until I'm 100% sure it works. Okay, cool. So then we're going to do 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now, I can actually enable that log. I actually like that log. Okay, and that should take care of that. Alright, so I think we're gonna go take our break, but I want to make sure I didn't get lost this section. We have this try and the accept and the accept. So when I come back, that's what I need to add in, is the proper code for this try accept. And you know what? I can't remember actually why this crashed initially. It's not a huge deal, because I can just rerun it to figure out why it crashed. I know that I wanted to remember this while server game start is equal to true. Okay, so we need to finish this as well. I'll put. Do we actually need, so the next question is, do we actually need self.game logic to determine whether we need to check if the game started. Didn't we determine it would be implicit that the game that both clients are connected, etc., that this logic is redundant / silly. Alright, so now I'm going to go take a break right here at G22. Alright, I'll be back in just a few. Oh gosh. Oh shit.
As we care for the election, it will be something, and some bird flu is what they're going with. The report of the New York Post, as you just heard, opens her report by saying that the bird flu could be 100 times worse than COVID. But she doesn't explain how she's coming up with that number exactly. Later on in the video, she says that 52% of humans who have contracted bird flu since 2003 have died. In that hypothetical universe, the bird flu will be far deadlier than it would have been if the public health establishment had lied to us for years about COVID. Public health authorities proved with COVID that we can't trust anything they say. So if there is a once-in-a-lifetime pandemic, an actual real one this time, we'll have no choice but to ignore them or at best, take them with a massive grain of salt. And of course, in turn, that will provide them with the pretense to use even more force than last time. So in a way, their own flagrant untrustworthiness becomes a benefit to them. It guarantees that we will defy them because what other choice do we have, which gives them the excuse to be authoritarians. A year ago, the head of the World Health Organization delivered a speech about the next pandemic, which he said was inevitable. And he made it clear that he understands very well that people will be hesitant to ever obey public health officials again. So to counteract that hesitancy and to ensure equity, he says, the head of the WHO insisted on changes that, quote, must be made, launch.
We cannot keep this can down the road. If we do not make the changes that must be made, then who will? And if we do not make them now, and when? When the next pandemic comes knocking, and it will, we must be ready to answer decisively, collectively, and equitably. And for enhanced international cooperation, the pandemic accord, a generational commitment that we will not go back to the old cycle of panic and neglect that left our world.
Okay, so we're back. Feeling a little bit done with this. We are at 3 hours and 44, 2:22. That was a 12-minute break. Okay, so that was a little bit long. But I think what I'm gonna do is I'm gonna go 1 more hour and we'll call it quits after that, okay? Alright. So here's what we're gonna do. Let's do this, what I put. Which was right here, 2.2, review, logic for server, game started. Okay, so let's see if we actually need game started, because we thought we needed it, but then I'm pretty sure we came to the conclusion that we actually didn't need it. So currently we have it here, and this well, server game started equal to true. Yeah, like wouldn't we just be able to like game started means both clients. We already removed this section which assigns game started, so like we kind of have to remove it. I'm pretty sure it's redundant, like we don't need it. I don't know, maybe I needed it before, but I'm almost certain now we don't need it at all. So here's what we're gonna do. We're gonna get rid of it. So this is gone. Let me just make sure one more time. Game started. Make sure I don't have another place that I'm just not looking at, but yeah, that's it. There is no other. I was just thinking, do I need like try and except for up here? I mean, server bind to server listen, server start accepting clients. I suppose, I guess I would just put this entire section. So we don't have a while loop, so why would we need break? Duh. If we don't have while, we don't need break, so, let me see. Do I need OS exit at the end of the script? Do I need os.exit at the end of a Python script? Okay. No, you generally don't need os.exit at the end of a Python script. By default, Python scripts terminate by themselves. Shit. Alright. By default, Python scripts terminate by themselves when they reach the end of the main program block. Here's why OS exit isn't typically necessary. Implicit termination. When your Python script executes all the code in the main block, usually indented under the if name is equal to main guard, and reaches the end, the interpreter automatically cleans up resources and terminates the program. OS exit behavior. While OS exit can be used to explicitly exit the program, it's not mandatory. It can be useful in specific situations, such as exiting with a specific status code to indicate success or failure. Here's a breakdown of when you might consider OS exit. Early termination. If your script encounters an error condition and you want to exit immediately, you can use OS exit to halt execution and optionally provide an exit status code. Exit status code. The OS exit function can take an optional argument, which is an integer exit status code. This code can be used by the operating system or other programs to understand how your script terminated. 0 for success, non-zero for errors. Example, early termination with exit code, Python, OS exit 1, error 1, okay. Sufficient for termination. OS exit can be handled. Okay. So We don't need that. Not here. Well, okay, well, actually, whenever we're multi-threading, like, okay, so in the case that we were multi-threading, and let's think about this for a second. If we're multi-threading, okay, and we have 2 client threads running, let's say for whatever instance the game is just done, both players finish the game, they choose not to play another game, like, wouldn't it at this point, like those 2 threads would still be running? When would those 2 threads stop? That's the question, is when would this thread... So this thread is not going to stop unless they chose to... if they chose to quit the game, that would... So if they chose to quit the game, so, okay, I'm thinking about something that I never really thought about before, which is, aside from that, like whenever they're done and they're gonna quit playing, doesn't that, the fact that this is an online game, like, and it's like the server doesn't shut down. You know, the server, like for World of Warcraft and, you know, games like that have servers, the server doesn't shut down. If the server shuts down, nobody can log on to the game. But if the server is up, then you can connect. So, like, in that vein of thought, considering that's what this game aspires to be in its final form, shouldn't the server never terminate? Because, yeah, I would think it wouldn't terminate, because if it did, then people wouldn't be able to connect to it. So we would have to add in logic for, well, I mean, also, like, you know, how many games can you host? Like, you know what I mean? I'd have to add in, that's another layer that I have yet to get to, which is adding in, you know, that code which allows us to have multiple games running simultaneously, and you know, properly disconnecting from sockets and all that when players are done, etc., etc. Okay, so I am, yeah, just thinking about that. How exactly would we implement that? I'm just gonna add this to things to do, and we'll put that off to the side for now, because that's something that we would need to do, but not for now. This is gonna be later, so. Secure sockets are being closed after connection via socket close. Ensure sockets are being closed after connection errors. With statement. So we started using. Can you use with threading? In Python, can you use with threading? Python King. Python, can you use with in threading statement for threading? No, you cannot use. Wait, you can't? The with statement is designed for managing resources that implement the context manager protocol, which threads themselves don't. Oh, so threads are not context managers, which means I can't do that, actually. While threads aren't standard context managers, some third-party libraries might provide custom thread classes that can be used with. These libraries often handle thread creation, management, and termination within the enter and exit methods of their custom class. Thread termination with flags. Finally, you can design your thread logic with a termination flag and a try finally block. Set the flag within the thread function when termination is necessary. The finally block can be used to perform a cleanup operations before the thread exits. Thread equals threading dot thread. Target equals my thread. Terminate flag equals true. Terminate flag. Finally, cleanup operations, for example, closing files, print thread cleaned up and terminated. Create and start a thread. Commit to work in the main thread. Set the termination flag. Wait for the thread to finish. Okay. Event objects for signaling. Threading module provides the event objects for thread communication. So we already actually verified that the thread will clean up on its own when it's done. So we don't even need to use that with. We learned that. And we also don't need game started at all, so we can go ahead and just get rid of that completely. So let's just get rid of that shit completely. Goodbye. And then let's go to So that is back to how it was. Okay, so that's taken care of. One thing at a time. That's all we can do, and we don't need OS exit. We determined that. Alright. Well, this is a lot cleaner than what it was. Let's go back over here. Improve logically with threads. We took care of that. Ensure sockets are being closed after connection errors via socket.close. So that's something we can take care of. But let's do this. Why is this? Oh, I forgot to. Was it clean up? Alright, we're gonna go for. It's 4:10. I think we're supposed to go 20 more minutes, 21 more minutes, and then we're gonna stop, okay? 21 more minutes, guys. It's the final countdown. And I'll tell you what. Music's kinda. Need a little better. There we go. It's better. That'll wake me up a little bit. It's kinda like putting me to sleep. Okay. Okay, so let's go ahead and add in these. So we have this threaded caramel, we got the try, and pretty sure the traceback log function will print the track in the case of this exception, which it would have a track because it would be from an error. So yeah, it definitely would include the exception information. So we're going to put in these different connection refuse error, connection reset error, and timeout error to handle these connection errors. And then we're going to do except whether or not they got the exception was for a connection error or another regular, like a different type of error, they both imply that they have crashed, that we're no longer in the main while loop, which means there's not the transfer of data going on anymore. Oh, and you know what I just realized? For subsequent well, actually, if just think about this, if they had a different type of error, then, you know, like, I don't know, I'm just trying to think of what type of error would they get, I don't know, maybe, like, they could re-enter into the while loop. I'm just trying to think of like how exactly that would work. So if a player DC'd and then went to go reconnect, I'm trying to figure out if, okay, so if a player crashes for whatever reason, let's just say like they just randomly exit out or whatever, I don't want it to mess up the server. So whenever we run another threaded client, I want to make sure that it is going to work properly. Well, this section right here, while self-verified ID received is not equal to 2. Because don't we have to... Yeah, we have to send the ID to the client when it reconnects for them to know what their ID is. So, let's not here. So we do socket is equal to n connect client ID equals none. And then while client ID is equal to none, we get that ID. And that's gotta happen, because otherwise client ID is going to equal to none. So this is directly tied to the running of this section. Well, to this actually. So but technically though, get client ID, so get client ID, that's going to handle that. Let's see. Client ID string, and then verify received. Yeah, so we need to make sure that this runs. So what we need to do is reduce self.verified ID received back to -1 whenever a client disconnects. So we need to set this to whenever a player DCs, which would So I guess currently as it stands, we'll just assume that if they have any exception at all, we're going to assume that they have been disconnected and are therefore like unable to play the game, and they have to rerun the client basically. They have to exit the client and then restart the client again. So we're gonna go with that idea. So let's do copy this, and then we're gonna put this down here. Let's see. Okay, I'm about done. Okay, I got 3 more minutes. Cool. So we're gonna go ahead and wrap up. I want to make sure I didn't leave any loose ends here. Okay. Yeah, I think that was good. It was kind of like it wasn't so much coding. It was more learning and refreshing and brainstorming on how to get this broader, you know, the outer shell, we can call it, of the server that, like, you know, the main section of the game, the boilerplate, whatever you want to call it. It's not really boilerplate. The core of it, the edges. I don't know the proper term, but anyway, server file. We got that cleaned up pretty good, and I think this is a lot better. We added in our try excepts. Yeah, I'm pretty happy with this overall. We got rid of some dead code. It's a lot better than what it was, and we like refreshed ourselves to where next time when we do some game testing, I'm going to be a lot more confident in the stability of the outer framework of server file and all that, and the interaction between the client and the server, so that we can get past those initial stages of the game and actually get into some core gameplay testing and work out those bugs, and then get this project finished up, you know, this stage of the project anyway, and move on to the next, you know, the next big thing for it, which still don't know what that's going to be. Database, website, I don't know. We'll see. So anyway, 10:45 to, we'll just say 3:15, because I took a little extra break. So we'll say 3:15, and how many hours is that? Let's do the math. So let's just say 10:45 to 3:45 is 5 hours, but minus a half, so that's 4.5 hours, right? I think debugging via game testing, and this was actually more like to 2 o'clock. Well, more like till 12:30. Fixed some minor bugs. Most all of them were associated with server pi initial structure. And then from 12:31 to 3:15 or 3:12, we did improved / refactored server pi's overall structure to improve logic and remove dead code, etc. Conform to DTM changes. handling client reconnection. Overall aesthetics. Solid products. Alright. Pretty good day, I think. So let's go ahead. Oops. Don't forget, the final thing is going to be 313 to 315. And that's going to be, we're going to stage, commit, push those changes. So let's go ahead and copy all of this. We're going to go down here. We're going to do git branch, and we're on the right branch. We're not in the correct directory. We need to cd out to the main project directory, and now we're going to do git add dot, and it's going to add everything. We didn't get any LF warning, which is kind of weird. Why didn't we get an LF warning like we usually do? That's strange. Do that again. Okay. Anyway, let's get rid of our apostrophes that are going to make us disallow us from being able to submit this. There was only a couple that time. So let's see the damage. We changed 3 files, 215 insertions, 211 deletions. So overall, I guess that means we added 4 lines of code. Yeah, I mean, that's good. Now we're going to git push Canasta secondary to push to the Canasta repository in the secondary branch, which is tied to this local secondary repository. And it successfully did that. So now we're going to make our local copy. You know how we do this. We go to programming, projects, Canasta. We copy this directory. We go out to the backup. We delete the old. We paste in the new. Let's try that again. There it goes. It takes a little while because of the assets. Now let's go into it, into text, into devlog specifically to make sure that it's reflecting the latest changes, and it is because today is the 10th. So now we can go back to the folder for the backup and change the title to the date of the last backup, which is, you guessed it, today. Alright guys, that's it. Have a good one. See you next time.